Hello, Matthews Gatos here. In this video, we are going to cover logarithmic word problems. Let's get started. My first word problem involves sound. So sound is something that is measured in decibels. If we have sounds that are at most 100,000 times as intense as a whisper, considered to be safe, and a whisper measures 20 decibels, what sound level in decibels would be considered to be safe? So I can see I have my decibel scale on the side here. So 20 decibels, a whisper, is right here. So this would be my whisper. And so I can go up to 100,000 times as intense. Now, every time I go up by 1 unit on that, so from 20 to 30, it's a sound intensity increase of a factor of 10. So I can use my log scales to help me with that. Now, important to note that when we are talking about sounds, we need to remember that it was Graham Alexander Bell that invented the sound, not Graham Alexander decibels. So we need to remember for our log scale, we need to switch it into bells. Now, 20 decibels is the same as 2 bells. I know my sound is going to be somewhere above. So to figure out how much above it is, I'm going to say that 10 to my new sound minus 2 bells is going to be an intensity factor of 100,000. So I want to solve for x. Now, this is a nice question because both sides of the equation can be written as a power of 10. The first one's already a power of 10. This one here is 10 to the exponent of 1, 2, 3, 4, 5 zeros. So it's 10 to the exponent of 5. So if we have an equation and we have exponents on both sides and the bases are equal, the exponents must also be equal. So I would just add 2 to both sides and I would get x equals 7. Now remember, that is 7 bells. So to put it back into decibels, I multiply it by 10. So 70 decibels. So up to 70 decibels would be safe. And if you look at this, this is a factor of 1, 2, 3, 4, 5. I'm going up 5 units on my scale, which is 100,000 times more intense. Another application of logarithmic scales is the Richter scale. So for example here, I want to know how many times more intense is the recent earthquake in New Guinea measuring 5.5, so right about there, compared to the recent earthquake in California measuring 5.1. So just above 5 at 5.1. So I want to know how many more times intense is the 5.5. So that one's more intense. So I'm going to do 10 to the 5.5, take away 5.1. That will give me my intensity factor. How many more times intense? Now, I know from here to here, it's not even a full unit. So it's going to be less than 10 to a power of 1. So if I do 10 to the 5.5, take away 5.4, that's 0.4 is equal to my intensity factor. So all I'm going to have to do is put this into my calculator. So I put into my calculator 10 to the 0.4 or 10 to the 5.5 take away 5.1, and I get that the intensity factor is 2.5. So it is about 2.5 times intense than the earthquake measuring 5.1. Okay, my third application of logarithmic scales comes from pH. So pH measures the alkalinity or the acidity of a solution. So in this question here, I have solution A that has a pH of 9.2, so right about there-ish. And solution B is 20 times more alkaline than solution A. Now I know my alkalinity increases as I go along, or it becomes more basic. So I know that my new one is going to be somewhere down here because it's more alkaline. Now it is 20 times more alkaline, which is my intensity factor. So my intensity factor is going to be 10 to the more alkaline, subtract the original pH of 9.2. So I know that when I'm solving for this, the number will be greater than 9.2. So to solve for this, I know it is 20 And then to solve when I have an exponent in the variable, I'm going to switch to log form. So remember, we love logs. They are our bay. So that stands for B for base. So I have log, the base is 10. A stands for answer, 20. E stands for equals exponent. So I would just literally add 9.2 to both sides. Now log base 10 is just the common log. So I can say log of 20 plus 9.2 equals A. Then I would just be punching this into my calculator to get what my A value is, which would be my pH of my solution. So plug that into my calculator. Where is it? There it is. Log of 20 plus 9.2, rounded to the nearest tenth, so we knew it was above. So now I know that the pH of the other solution is 10.5. So speaking of acidity and alkalinity, I have one final question for you, and that is, what do you call an acid with an attitude? Well, you would call it amino acid. I hope this video helped. If it did, please give it a thumbs up and hit subscribe so I can help more mathies just like you. Thanks for watching, and I'll see you for the next one.